Good morning, good afternoon, or good evening, depending on where you are, and welcome to this Techstrong learning experience brought to you by Fairwinds. We've got an exciting program ahead, but first I have just a couple of housekeeping notes to go over. Today's session is in fact being recorded, so if you miss any of our discussion, you will be receiving an email with a link to access the recording on demand shortly after we finish our live session. Now, to interact with our speakers today, you'll want to look over to the right side of your screen. There are a couple of options. First option is the chat tab. I'd like you to start warming that up for us right now by letting us know from where you are tuning in. Feel free to also use this section for any other comments or concerns you have during our conversation today. For any questions, go ahead and send those over to that next tab that says Q&A. We'll try to address those as they come in, but if we don't get to it right then and there, we will try to get to it by the end of the program. We do have 2 polls that we will be launching throughout our session today, so feel free to respond to those as we'd really like your input there. If you check out the handouts, there are, looks like 2 different resources there available for download, so feel free to grab those. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. The topic of our conversation today is getting Kubernetes costs under control. And I'm joined by Robert Brannon, Vice President of Product Development at Fairwinds, and Kendall Miller, Technology Evangelist at Fairwinds. Robert and Kendall, thank you both so much for joining me once again. Kendall, do you want to go ahead and get us kicked off?
I do want to go ahead and get us kicked off. Thank you, Cody. Robert, you ready for this? Here we go.
I'm ready. Let's do it.
All right. Well, so hello, folks. Welcome. This is getting your Kubernetes costs under control. You know, we have this amazing piece of technology called Kubernetes that does all kinds of things for us. Unfortunately, as a result of that, it also affects cost for us sometimes without us knowing. So the beauty of not having to minusculely control every single thing all the time manually has its advantages, but can cost us money. So we're going to be talking about that today. What makes Kubernetes unique, how that affects cost, how that affects what you're doing, and then we happen to build software that addresses some of this, so we'll be talking about that as well. But without further ado, let's dive in. Robert, you want to tell us about yourself, introduce yourself?
Yeah, hey folks, my name is Robert Brennan. I'm VP of Product Development here at Fairwinds. I've been working with Kubernetes for about 5 years now, and working in open source for probably close to 10. So very, very excited to be here. Very excited to talk about cost in Kubernetes.
All right. And hey, folks, my name is Kendall. I'm a technology evangelist here at Fairwinds. Been involved with the company for 8-ish years, a very long time. And we've been talking about Kubernetes for all of that time. Been talking to lots and lots of folks about it off and on for many, many years. Excited to be here and talk with you about it. And I say talk about Kubernetes with people. I just yes, RBAC manager, shout out in the chat. I'm sorry, that was very exciting for me. RBAC manager was one of our first open source projects, and it excites me. No, I was telling Robert just today about that. I met somebody who was involved at Google working on Spinnaker for a while, and I heard a long rant from them about the pluses and minuses of Kubernetes, and it made me laugh because it's been a long time since I've heard people say, should we be doing this? And he was making that argument long after Kubernetes has received wide adoption. So before we get started, let's do a poll here. What percentage of your infrastructure is on Kubernetes or planned to be migrated in the next 6 months? And we have used, because we asked what percentage, we're giving very specific percentages here as possible answers. So some of the percentages are none. Some of the percentages are some. Half is a 50%, and all of it is a 100%. So you're going to have to do a little bit of figuring out where, I guess some is the only one that's really kind of questionable, but I'm assuming since some is between none and half, you can guess a 25% range or somewhere in there.
Anything between 50%.
I guess less than half
is off.
Yeah. Anything between 50% and all in is off the table. That's exactly right. Okay, here we go. And Cody's pulling up results for us. So all of it, 30% at all of it, 30% at some. Okay. You can keep those results coming in. We'll keep the poll open for a second here. This is actually interesting. I guess in a cost-related webinar, it makes sense that there would be some people who, or a large number of people who would be all in on Kubernetes. We do a lot of webinars covering a lot of different topics. Sometimes like everybody's just getting started. Sometimes everybody's got a little bit working. So this is kind of interesting, the sum and all dichotomy, but makes sense. Okay, you can leave that up for, well, you can close this screen here, Cody, and I'll move on. But if you haven't answered that poll, maybe it's too late. I don't know. But we'd love your feedback. It's always interesting to hear. Okay, so real quick, why are we talking to you about this? So, I mentioned we've been talking Kubernetes at Fairwinds for a really long time. I've been involved for a long time thinking all things Kubernetes. Fairwinds has been around for a long time, and we provide software for platform engineers who are running Kubernetes to standardize and enable development best practices. Standardize, automate, and enforce Kubernetes best practices to ship applications faster. So everybody struggles with Kubernetes particularly when they first get to it. And platform teams out there at any kind of serious scale are working really, really hard to build repeatable processes so that they can standardize, so that they can automate, and so that they can enforce best practices, because you either have a small platform team that has to go around telling everybody what to do all the time and educating them on everything all the time, or you have a platform team that builds great tooling so that people can just ship software relatively easy, right? And that's where we sit, is try to help out those platform engineering teams who are sitting between developer and Kubernetes so that people can ship software quicker. And that's what Fairwinds does. So we've been in this space a long time. So we have services in this space, a whole bunch of open source. Back to the, RBAC Manager was, I think, our very first open source public project. It's been out there for a long time, and we have several open source projects out there. If you use Kubernetes, one of our open source projects is probably relevant. And then we also have a SaaS product, which we'll get into a little bit later. But today, we're here to talk specifically about cost estimation strategies in Kubernetes. And the reason we're talking about this is, as I mentioned at the very beginning of this, Kubernetes does a lot of logic for you in terms of scaling up your workloads, scaling them down. It is incredible software because, and I know this because in 2015, before our company was all in on Kubernetes, we were building a software product that made it repeatable to scale up and down infrastructure and deploy applications and get them to work. And, all the things that Kubernetes does magically today, everybody in 2015 was trying to figure out how to solve on their own. And Kubernetes has come along and made that a lot better. So we're out of the world of, I buy a computer, I stick it on a rack, I know exactly how much it cost me because I bought that computer and I stuck it on a rack, to the promise of the cloud, where Robert can have a SaaS idea and spin up 5,000 machines in AWS in 2 minutes. And there's all the pluses and minuses therein. But when Kubernetes is doing that for you, it says, hey, how about 400? Hey, how about 200? Hey, how about 10? How about 20? So it's difficult to estimate. It's difficult to estimate individual workloads in that. It's difficult to estimate when things are scaling up and scaling down. But we've worked really hard to figure a lot of this out because our software product offers cost insight. And we're going to get into that. But Robert and his team have built this out. And so Robert really understands this problem inside and out and is going to help us dig in and understand cost estimation strategies and what's unique about this. So let's start with this diagram and why we're using this diagram and just a baseline of what CPU and memory is, Robert, and I'll turn over to you.
Yeah, so the biggest, cost driver in Kubernetes is the usage of CPU and memory. So every node that's, powering your Kubernetes cluster, which you're actually renting from AWS, comes with a certain number of CPUs, a certain number of gigs of memory. And then every app that you're running inside of Kubernetes is going to require a certain amount of CPU and a certain amount of memory in order to do its job. And so Kubernetes, whole shtick is saying, okay, I've got, this many nodes with this much memory, this much CPU. How do I take the workloads that you want to run and stick them, bin pack them into those nodes so that, I'm getting the most out of the CPU and memory that I have. There are other costs associated with running workloads in Kubernetes, things like disk, network traffic, load balancers. We're not going to go into those today. CPU and memory are the biggest drivers of cost. And generally the same principles apply for those other things. But CPU and memory are kind of the hardest to get right, and they are the biggest the biggest items on your bill from AWS. I do want to point out.
And so, go ahead.
I was going to point out the this diagram here on the right is something you're going to see throughout this presentation. This is a representation of a node with, say, 5 CPUs and 5 gigs of memory, and we'll start sticking some Tetris pieces into this to see how Kubernetes kind of fits workloads into that node.
Yeah, so a lot of what we're talking about today is how Kubernetes bin packs, right? So we're going to get to that and making sense out of people requesting CPU and memory, right? So I think it's useful to say when we had the world of hardware, you bought a computer with a set amount of CPU and memory, and your application used what was there until there wasn't anything left, and then it died, right? And in the world of Kubernetes, we declare how much CPU and how much memory we think the workload needs or wants, et cetera, and we hand it to Kubernetes, and we let Kubernetes run a bunch of logic with that. And the declarative world, maybe it's the best thing ever, maybe it's the worst thing ever, depends on who you're talking to, but that's where we're at with Kubernetes. So I want to pause before we move on and just say, to Cody's point in the chat, we will be answering questions throughout. If you have questions, feel free to put them in the Q&A tab, so you can pop over there, type a question in, hit send. We will see that. We will address them either in the moment if they're relevant, or at the end we have some time for Q&A. Feel free to ask us questions. Cost and Kubernetes is a world that Robert has lived in for a while now, and he knows inside and out, and probably is happy to talk about. So anything you have related, go for it. Okay, so with that baseline set, let's dive in. Bin packing.
Yeah. So
right-sizing nodes. Yeah. Good. Just explain what it is and why it's problematic. Go ahead, Robert.
Yeah. So bin packing is what we refer to Kubernetes algorithm for basically taking these are the workloads that you've asked it to run. These are the nodes that it has access to run those workloads. How do I fit the things you want to the workloads you want to run onto those nodes so that I have resources for everything available, and I'm not wasting resources. So in the example we have here, we have a workload with that little square all the way on the left. It wants 2 CPUs and 2 gigs of memory. We've got nodes with 5 CPUs and 5 gigs of memory, and you can see, as my workload starts to scale up, I can fit 2 instances onto a node, but when I want a third instance, I can't use that last gig of memory and last CPU that's left on that node. I have to go to a whole new node because I can't put half of a workload on one node and half of a workload on another node. And so I end up with this unused capacity in each of my nodes, right? So a good solution here is to what's called right-sizing your nodes. So picking a node size that you're going to be able to fit, most of your workloads onto. Generally speaking, sizing up your nodes is a good way to reduce the amount of waste for each node, because you'll be able to basically fit more onto. You'll have fewer nodes and you'll have less of that hanging room left. But the node size that you choose is important to make sure you minimize that waste and minimize any overhead that goes into running your Kubernetes cluster.
Yeah, and okay. Well, I was gonna ask a leading question as it relates to the next slide, but I guess I'll wait for the next slide. Anything more to say on that before I move on, Robert?
Yeah, I think we can move forward.
Okay, so yeah, this it's worth saying I like the Tetris idea here, but also literally if you went to a container store and you bought a certain size box and what you have takes up 2/3 of that box, or you have things that you just can't fit, either making the box smaller so that it perfectly fits things, or getting one that's twice as big so you get 2 of them in. There's ways to think about this logic. I think that's really obvious. I just want to be explicit that that's literally what we're talking about, is fitting the right amount of things into a bucket. So let's talk about resource asymmetry.
Cool. Yeah, so in that last example, we had a workload that was using, memory and CPU in the same proportion to the memory and CPU that we had in our nodes, right? Here we have something that's using a lot more CPU than it is memory, right? This is a very CPU-intensive workload. And you can see if we, tried to fit another one of these onto this node, it's not going to fit CPU-wise. We're going to have a whole new node. And you have a ton more wasted space here, because not only do you have 2 wasted CPUs, you've got 4 gigs of wasted memory here. And so when you have these workloads that are very lopsided, either very CPU hungry or very memory hungry, you have to start thinking about different node types, right? There are node types from Amazon that are going to be, have more CPUs than memory, and there are node types that are going to have more memory than CPUs. So that if I'm running very CPU intensive workloads, I can ask Amazon or Google or whoever else for CPU optimized nodes that have a ton of CPU available relative to the amount of memory they have available. This is a very important, always look at.
I mean, Robert, is that a thing? I literally have to call my Amazon rep and be like, hey, what the heck? Or is it a click button in my dashboard? Or is it real obvious when I look at MX in 114, whatever it says in the names? Is it describing how that works? Or how do I actually figure that out? Make sure I get the right node size.
There's both on Amazon's website, and there's some little helper tools, little open source tools that list out the entire inventory of Amazon's instance types. And you can see this one has 2 CPUs and 4 gigs of mem. This one has 2 CPUs and 8 gigs of mem. So that's let's go with that one for our more memory intensive workloads. So it's pretty easy to look at an instance in Amazon or Google and understand what's that memory to CPU ratio. What's a little bit harder is looking at your actual workloads and understanding how much memory and CPU are these workloads using, how much do they actually need, how much have my developers asked for, things like that are a little harder to wrap your arms around, and we'll go into different ways to do that a little later in the presentation.
But the point is, Kubernetes doesn't understand what all the node types are underneath, and it doesn't pick those for you.
Right. Yeah, there are like Carpenter, which are kind of up and coming tools that will help you pick node types based on what you need. But those are very advanced. They need a lot of configuration. I think, for most people, you're going to want to pick a node type and stick with it. So you have a very predictable environment.
Yeah. So we just had a question come in that says, well, why don't we just use Carpenter, which places the right node in such a case? And the answer is you might not be able to, or it might take too much, why don't you just is almost always related to because you don't have the capacity or the time or whatever. So for what it's worth. And then on the resource asymmetry, I can't just flip this around and turn this piece upside, in our Tetris analogy, I can't just be like, well, I'll just slot another one in upside down because that would be a whole bunch more memory and less CPU, which isn't how my workload's designed, right?
Right. But, to that point, if you did have a large variety of workloads at your company, some of them are very CPU hungry, some of them are very memory hungry. Kubernetes might be able to sandwich those together very nicely in this node and, pair them up so that a CPU hungry one and a memory hungry one always pair up on each node. Chances are, your organization, it goes one way or the other most of the time. But sometimes you can get lucky, and Kubernetes does that bin packing very intelligently when it does have the opportunity to.
Yeah. Great. Okay, so let's talk about cost attribution. How do we figure out what these things cost when they're shaped like all these different weird things?
Yeah. So the first difficulty here is coming up with like a cost per CPU and a cost per gigabyte of memory. Typically what we like to do is say, okay, this node has 2 CPUs and 2 gigs of memory. It costs you $4 a day. We're going to say that's $2 a day of CPU and $2 a day of memory, or $1 per CPU, $1 per gig of memory, right? So we just basically divide it evenly between whatever amount of memory is in there and whatever amount of CPU is in there. But it's kind of up to you, what you want to charge per CPU, what you want to charge per gig of memory, how you want to divide those costs, those node costs into CPU and memory. Even once you have that, though, we have this issue of, okay, I have a workload with, say we're going to, say we have a even split of, it's $2 per CPU and $2 per gig of memory. If I have a workload that is nice and square, like our first example, where it's using a similar amount of memory and CPU, and it's going to bin pack very nicely into our nodes. We can pretty optimistically say, it's pretty clear what that's going to cost. When we have a very asymmetrical workload like that second workload, which uses a lot of CPU, it might not bin pack very efficiently. We might end up with a lot of wasted memory. And so we recommend two different methods for calculating how much a particular workload costs. The optimistic method basically assumes Kubernetes is going to bin pack very efficiently. So if you've taken the time to, pick the right node types, or you're sure that you have, a large variety of workloads that will bin pack very nicely, the optimistic method will probably give you a more accurate picture of things. And it basically just gives you a straight charge for, you've got this many CPUs, this many gigs of memory. We're going to charge you, $2 per CPU, $2 per gig of memory. And it comes up with, $8 as the charge for both of these workloads. The conservative method, go ahead.
Yeah, well, explain the conservative, then I'll ask my question.
Cool. So the conservative method basically, it assumes that it doesn't assume that you're going to get efficient bin packing. It assumes that there's going to be some waste when you have a very asymmetrical workload. So it penalizes asymmetrical workloads. So in this example, we have a workload with 3 CPUs and only 1 gig of memory. The conservative method is saying instead of $8, this is actually going to cost $12, because it's basically saying that we're going to have two wasted slots of memory here. So it's charging you for the maximum of your CPU and memory usage.
Yeah. Well, so to your point, well, first of all, which one does Kubernetes do more often? Is there an obvious one?
So if you've got a big cluster with a large variety of workloads and relatively big nodes, the optimistic method is pretty safe. If you've got a smaller cluster with few nodes, you haven't done any node right sizing or looked into this at all, you've got one type of workload that runs throughout your organization, and that's all you run. You just run 200 pods of the same API server. Then the conservative method is probably going to be more accurate to your cloud bill.
And how common is it for the average organization to have picked the right size nodes, or for people to even be? Well, answer that first, and then I have another question.
I'd say it depends on the maturity of your organization. If you have, a FinOps team that's looking at this, if you have a dedicated platform team that's has the time to do all these calculations constantly and be looking at it every quarter, are we still right sized? Are we still doing this right? Then you're probably, should go with that optimistic method. You probably have, a very good bin packing going on within your cluster. If you don't have a platform team, if you don't have a FinOps team, if it's just your developers, with, half a developer managing the Kubernetes cluster in his spare time, her spare time, it's probably better to go with the conservative method and assume that there's some waste going on under the hood there.
Yeah. Okay. And is it, one last question related to this, is it wildly different or easier to get node types wrong or better? Or if I go buy a bunch of hardware and I'm running Kubernetes on my own hardware, it's probably really hard to get node types right. So I better have a whole bunch of different workloads, right? Because I'm just going to have whatever I've got. I don't have the variety that Amazon's going to give me. If I'm in DigitalOcean, is it different? If I'm in is one cloud easier than the other, or is it just kind of all hand wavy and there's a million different moving pieces to make generalizations?
Yeah, I would say Amazon and Google give you the most variety of node types available. DigitalOcean has a much smaller menu, which makes it a lot easier to navigate, fortunately, but also gives you less wiggle, less fewer levers to pull in terms of picking nodes with lots of memory versus lots of CPU.
Did you leave out Azure? Which bucket would you put Azure in?
I don't have enough Azure experience, honestly.
I thought maybe it was a political statement. Okay, well, I'm going to move on from cost attribution. Are you ready for what's next?
Yeah, let's do it.
Okay, so yeah, resource ranges. Let's talk about this. The how do we get these things correct, even what we're requesting?
Yeah, so it's really important to note that in Kubernetes, it's not just this workload uses this much amount of CPU and this much amount of memory. You have a couple different things that you have to take into account. One is that every one of your workloads should be setting a request for the amount of memory and CPU that it wants. And Kubernetes will reserve that amount of memory and CPU. So you can say, okay, my API server, for every pod that's running for that API server, I need at least 1 gig of memory and at least 1 CPU. And even if it's only using half a gig of memory and a quarter of a CPU, Kubernetes is going to reserve that for that workload so that it can spike up if it needs it. If you don't set those requests, then Kubernetes might schedule it somewhere where only has half a CPU available. Then your workload tries to spike up and it doesn't have the resources it needs. And you have all sorts of reliability issues. Your customers start complaining, et cetera. So setting those requests and saying, please reserve X amount for my workload is super important. What makes things tricky in terms of cost attribution, though, is that your workload could spike up above that you've reserved one CPU. It could spike up to 2 CPUs if it, suddenly you got a bunch of traffic coming in. And so it's hard to say, this workload only used 1 CPU if it can spike up above that. So there's this second setting in Kubernetes called limits, where you can say, I'm going to reserve 1 CPU, but I'm going to limit it to 2 CPUs. So I know that this workload's always going to be allocated exactly, have 1 CPU, but if there's room, it will be allowed to burst up to 2 CPUs. So you can kind of start to wrap your arms around it. In terms of like what that workload should get charged, in terms, if you're trying to, for every workload you're running in Kubernetes, you're trying to come up with a dollar amount of how much does this workload cost me. It's a little bit harder because you need to be charging it essentially the maximum of what it's requested. So what Kubernetes is reserved for it that no other workload can use, and what it's actually using. So at every point in time, you have to be looking what's the maximum of those 2 metrics. And so it becomes some very tricky math to figure out, okay, how much CPU should I charge to this workload? How much memory should I charge to this workload?
Yeah. And how a lot of organizations don't get these requests and limits right.
Yeah.
Right. Which Fairwinds has open source software, and our SaaS product help with this because everybody struggles with it. You don't want your engineers clicking the Apple button at the top and saying about this Mac and then just typing in, okay, well, it has this much CPU and this much memory and it works on my machine, so that's what I'll request, because that's going to be wildly over provisioned in most situations. And I'm sort of joking that that's a possibility. I think a lot of organizations don't realize how much their engineers just don't have any idea how to right size those things. And so, having software that helps you get that right is helpful. But those ranges, I want to talk a little bit about those ranges too. Like, Robert, let's say I get hacked and somebody takes over one of my workloads and starts running, crypto mining. If I don't have limits on it, it can just go nuts, right?
For sure. Yeah. It can eat up all the resources in your cluster. It can cause cluster autoscaler to kick into gear, or whatever, autoscaling software you're using, and start, renting nodes from Amazon all of a sudden. And it can cause your cloud bill to skyrocket. It can cause issues with other workloads, which we'll get into in a bit. But yeah, you're right. It's something organizations get wrong. The easiest way to get it wrong is to not set requests and limits at all, in which case you'll probably find out pretty quickly, like, my customers are complaining about reliability issues. The app gets slow for no reason sometimes. And somebody will have the bright idea of like, oh, we should reserve a certain amount of CPU and a certain amount of memory for each of these workloads so they don't get killed and throttled. But as Kendall pointed out, sometimes developers are just making a guess. They're just, they're looking at their Mac and saying, well, I have 16 gigs of memory in my Mac, and I've got 8 CPUs here, so I should have that for every instance of the application. And then you look at the actual statistics of what it's using, and it's using, less than 10% of that. And that is very common for us. We help our customers with right-sizing workloads, and we often see those workloads are using, less than, 30%, less than 10% sometimes of what they've requested, even when they're at their most active, when they're getting the most traffic. And so we're often able to help folks save, sometimes thousands of dollars a month just by scaling down a few of their workloads and requesting less memory and less CPU.
Yeah. Okay, great. Kubernetes, this is one of those things that Kubernetes does really, really nicely. It just goes out there and allocates things for you and packs bins and lets the app run within certain ranges. Hey, what are they requesting? How much are they limiting? This is incredible technology that we used to have to do so manually, and there's just no reason to do it the hard way when Kubernetes will do it for you if you configure it correctly. If you configure it poorly, you're letting, it's giving the keys to your car to your toddler, and there's no reason to do that to Kubernetes. It's very good at following instructions, a lot better than your toddler, but it needs a lot clearer instructions because it doesn't, it doesn't know. Yeah. I don't know. I'm giving a lot of hand-wavy credit to toddlers' abilities in that statement. Okay, let's talk about noisy neighbors and how it gets messy when there's lots of things going on in a single node.
Before we move on, we did have a question come in about request deployments. So the question is, requests and limits can be set at the deployment level, correct? And are those resources divided equally? So this is a really good question. So requests and limits should be set at the deployment level. Basically, so just to for everybody's edification here. So in Kubernetes, you might create a deployment for, let's say, your API server, and then within that deployment, you'll get a pod for every replica of the deployment. So you might have 3 pods under normal conditions that might scale up to 10 pods, on Black Friday when you get a bunch of traffic, and then scale back down on the weekend when you don't have much traffic at all. And it's important to point out that if you tell that deployment, I need 1 gig of memory and 1 CPU, you're saying 1 gig of memory and 1 CPU per pod. So when you're running 3 pods, you're using 3 gigs of memory and 3 CPUs. When it scales up to 10 pods on Black Friday, now you're using 10 gigs of memory and 10 CPUs. Hopefully that answered the user's question here.
Yeah, it's the Black Friday example is a really good one because there are a lot, like every e-commerce company out there that operates in the United States, and there's different Black Fridays if you're in Asia, or whatever. But if you're in the US and you're selling there, Black Friday is this thing where you might do traffic like this all year round. And then there's 3 days on a one weekend of the year where you do this much. And if you're not prepared for it, it's, this is why the cloud is amazing. I just scale up for 3 days. I don't have to own 2 other data centers for the 3 days a week that have a big sale. But sorry, get back to noisy neighbors. What are noisy neighbors? Why do they matter? How do we avoid it? And I know we already talked about some resource requests and limits, so I jumped the gun, but go for it.
Yeah, no, it's an important topic. So in Kubernetes, if you don't set requests and limits on any of your workloads, say, Kubernetes will do its best to figure out, okay, where should I put these workloads? What node should they go on? But the issue is, say you've got a node with 4 gigs of memory and 4 CPUs, and you've got a couple workloads that at their height want to use 3 gigs of memory and 3 CPUs. Kubernetes might schedule those onto the same node, and then if they both try and scale up at the same time, one's going to run out of resources before the other does, right? There's going to be contention for those resources, and one of them is going to get an out of memory exception or have its CPU throttled because the other one's already using those resources. And so without those requests and limits set, Kubernetes can't intelligently figure out where should I put these workloads to make sure that they have the resources they need. If you only have one workload in there, not that big a deal, right? It's just competing with itself for those resources. This is why we say noisy neighbors is a problem, because if you haven't set those requests and limits on several different workloads, they might get scheduled on the same node and then end up competing for the same resources. One workload scaling up and down is going to affect this other workload over here. And that's a very difficult problem because, Team A is now responding to pages because their environment's falling over, customers are complaining, and they're like, our app is behaving normally, everything seems fine, why is it running out of memory? And it turns out it's because Team B over here hasn't set limits on their workload, and it's eating all the resources that Team A expected to be available. And so you get this weird cross-channel interference between different workloads that can cause a lot of problems organizationally. And the way to fix this is to make sure that you're setting requests and limits on every single workload. And I think in particular, if you've got production workloads that you care a lot about, setting those requests and limits to the same number is usually a really good practice. We call that a guaranteed quality of service in Kubernetes if you set requests and limits to the same amount, because you're basically saying, I'm going to, for every amount of memory, every amount of CPU I conceive this workload could ever possibly use, I'm going to reserve that. So it's potentially, allocating some resources that aren't going to be used all the time. So you might end up paying for some idle resources that way, but it's going to make sure that those resources are always available for that workload, and there's no variability in terms of Kubernetes scheduling, caused by Kubernetes scheduling, right? You don't want the reliability of your workload to be affected by where Kubernetes happened to put your workload, what node it happened to put it on, who else lives on that node alongside you.
Yeah, great. Another one more plug here for Goldilocks. I know that there are. This is one of our more wildly adopted open source projects out there, and for good reason, because people don't know how to set the resource requests and limits, and we've made it really easy. We actually just watch what it uses and make suggestions accordingly, which is really easy. So your developers don't have to sit there and go, what do I set this at? We can find out. Okay, so there's another question that came through here. Robert, do you want to address that now or later?
Yeah, no, I think this ties right into what I was just talking about. So yeah, the participant's asking about best effort pods versus burstable pods versus guaranteed pods. These are different qualities of service in Kubernetes. Guaranteed means you've set your requests and limits to the same level. Burstable means you've set limits above your requests. So that's great for like a development workload where it's going to sit idly most of the time, but then somebody's going to go and test it. Maybe if you're like staging server or something like that, and it needs some room to burst up into that that 10 minutes of usage as somebody's testing it, but you don't want to be paying for that all the time. You might set it to a burstable quality of service, and then best effort is just not setting anything and saying Kubernetes, do your best with this. And this user is correct. Guaranteed pods are going to have the highest quality of service. They're guaranteed to have the resources that you request for them. Burstable ones are guaranteed to have what you set for the requests, but the limits, Kubernetes will do its best. But, if you say, I request 1 gig of memory, set the limits to 2 gigs of memory, there's a chance there's only 1.1 gigs of memory available for that workload, and it's going to run out of memory. And again, best effort is the, lowest item on the food chain. It's going to get evicted pretty quickly by guaranteed and burstable workloads. So you're correct. The best effort pods are not going to evict the other two.
Great. So from here, I want to say, Goldilocks is a great solution to help you get this right. If particularly you have just a handful of 1 or 2 clusters, when you get to bigger scale, any sufficiently large organization is going to have multiple teams, multiple clusters. There's going to be a level of complexity where it becomes really untenable to stay on top of this. And what you want is software that helps expose this, maintain this, set policy around it, set limits on things, help you make, and you can go in and look at and say, hey, I would save a ton of money if I X, Y, or Z, right? And that's where Fairwinds Insights comes in, and I'm going to show you that here in just a second. Oops, skipped a slide there. 49% of Kubernetes workloads use less than 30% of the requested CPU. So basically half of all of the workloads that we've ever seen use less than 30% of requested CPU. So that's, specifying requests that align with the actual usage is kind of important. And an overwhelming percentage of people are getting this wrong. Okay. We can say that a lot of different ways. You're probably getting this wrong. That's the clearest I can say. Okay. What Insights does is back to my original topic of we stand sort of between the platform engineer and the developers, trying to help streamline operations, eliminate wasted compute, right size workloads, avoid lots of trial and error to be precise on those recommendations that you're gonna set for workloads. We do integrate with Prometheus to collect historical usage data. I'm going to show you all this in just a second. Fairwinds Insights exists to make this very, very easy. Now, that's just on the cost piece, and I'm going to focus on the cost piece in the demo that I do for you in a second. But I want to say that Insights does a lot more than that. So we cover reliability, we cover security, and we cover cost efficiency. And so if you're using Kubernetes, and what you want is same defaults out of a box, plus a tweakable system to write customized policy that meets whatever your company's needs are, that's where Fairwinds Insights exists. So we can decrease friction, improve the development experience, increase development velocity. Everybody says, oh, we increase the development velocity. I feel like it's a super common buzzword right now, but building tools that enable your developers to just ship software and move on does speed you up. If your average workflow is developer builds something, tries to ship it, runs into a problem, has to get a hold of platform engineering, pinging them in Slack, hey, why won't this work? Hey, what do I do here? I'm getting an error. I don't know what that error is. I don't understand that error. How do I move forward? That's shipping slow, and that's going to affect your organization. Let me dive into a brief demo here. I'm not going to show you everything in this product, because there's a lot here. But when you log into Insights, you get an overview of some of your problems. That's what I was just showing there. But here is a whole bunch of clusters. So I clicked into the cluster view. This is all these clusters running across my organization. and we give your organization an overall health score. And this is based on a whole bunch of things that we're checking across your organization and saying whether you're passing or failing, whether these are high priority or low priority. And I can dig into any one of these clusters. Actually, I think maybe not. I thought I had that open already. This is a production cluster here. This one's giving me a B+ as well. We're showing where action items were removed from the cluster. So things that we fixed in this chart, you can change this to fixed, new action items, whatever. You can change the last month, the last year, whatever you want. And then we track this health score over time. So you can see this cluster improve from a 94 to a 96 and then drop down to an 88, right? So issues were introduced into the cluster and the cluster score is being affected over time. It's nice to be able to track that and see it improve. And then here's some of our cost bits. So here we're actually seeing different workloads that are running in the cluster and what they're costing us. These are small numbers because it's a demo environment. And I'll get more into this in a second. So first of all, where this is all coming from, we leverage a whole bunch of different open source projects out there, best in class, third-party open source, as well as our own. We marry those together to operationalize them at scale for lots and lots of clusters. Any of these open source projects, you can go download today, run them on one cluster, and it's pretty straightforward. If you have more than one cluster, it gets really overwhelming really quick, particularly if you have more than one of these projects, and then getting it together in a single unified place where you can write policy against it, check for those things, make sure you're enforcing that at runtime, at the deployment time, at the admission controller level, et cetera. All of that is what Insights adds on top of this. But Polaris checks for common Kubernetes misconfigurations. This is one of our projects. Nova checks for out-of-date Helm charts, Pluto deprecated APIs. We also have Goldilocks integrated in here, all Fairwinds projects. But we support Trivy, which scans for known vulnerabilities. We have support for OPA. We also use KubeBench and KubeHunter and the Prometheus collector and a whole bunch of different things here, okay? So you can install individual bits of these, and we roll up what we find into a big list of action items. So this list of action items, we can filter by severity, critical, high, medium, low, see what our issues are. The critical issues tend to be security related, but we can filter by security, efficiency, reliability, and if you click into any one of these issues, memory limit set too low. Here's something that we're talking about, right? I can click on this. It shows me this is coming from the Goldilocks report, and this is what the issue is. Here's how to go and remediate it, right? We actually tell you how to go fix things. It's not just, hey, you have problems, and then good luck figuring it out, because we know a lot of the teams out there that are working on these things aren't the most senior people in the world. However, if you're a platform engineer and you're implementing these kind of tooling and you see this kind of thing where there's like a whole bunch of problems rolled up and you're kind of panicking, like, I don't want one more tool that shows me everything I do wrong. I know I do some things wrong. That's where we've implemented this at the CI process and the CI level. So here's Robert actually removing security and reliability configuration from Nginx because he's trying to prove a point. And you can see in a workflow that he's familiar with, there are action items and issues that are all of a sudden being reported. So these are severity low, but we can block a deployment as a result of this. So we can say, hey, anything that has high severity, you can't deploy. And we can keep a deployment from happening as a result of this. This is just a picture of this integrated with GitHub Actions. You can plug it into all kinds of things. Okay, that's a whole bunch to get to our efficiency tab. So this is where we're going to get into the cost bits because this is what we've been talking about primarily today. We break down cost across cluster. And so here, we're looking at the capacity and how many CPUs we're using. You can sort by all kinds of different things, CPU, memory, the most recent data, et cetera, across all your clusters. We track that cost across all clusters. Here, all of our demo clusters got more expensive sometime around the middle of February. Thanks, Robert. And the capacity here, we track that as well as utilization. All of these charts are adjustable. We're looking at CPU right now. We can dig into memory. We can go to the workloads tab, and I'm going to select that same cluster. And here we break down by workload. So what percentage of things are using what percentage of, are eating away our costs. So here the API is taking 26.8%. Great, that makes sense. Hopefully the API is taking a larger percentage than Pluto. The relative daily cost as we go throughout this, the daily cost over time, and then here you see the quality of service, right? So here's a critical workload, and it's Prometheus server, which we are giving a recommendation around the average total cost. So in this situation, we're saying you can save a bunch of money. Now you'll see up here, we're telling you to spend more money because you want a guaranteed quality of service on the API. And so we think you should improve that and change that. So here we have where your memory, your recommended requests and limits are, and then where your actual requests and limits are. Where is the actual? Yeah, where is the actual on this one, Robert? Help me out. Normally I see a separate line and I don't see it.
It's that giant blue area. Is the bottom of that?
Oh,
blue
this
area.
is what's currently. Yeah.
Yeah.
Okay. Yeah. So this is where we make this really obvious, what is actually being used, what isn't, and we make suggestions for how to go in and tweak that. And that's memory, that's CPU. We collect that over time. Oh yeah, so here's the request, here's the limit, and here's where our recommendations are. Does that make sense? That's based on the quality of service. Now, we're also, with AWS in particular, we get into some very specific costs over time. We can break this down. Assuming the demo gods let this load while I'm live streaming it. Yeah, there we go. Okay, so costs over time, total costs over 28 days. Here's what we're actually spending in this particular cluster. We can compare them across clusters. We can see the top namespaces, the top workloads across our entire organization. There's lots of ways to break this down and even see all of our clusters, which one's the most expensive, how many pods are we running, how much did we actually spend. If we took all of our recommendations, how much would we save? On this cluster, we're going to save $14. It's not a big deal. It's a demo cluster. But that's the kind of thing that you're going to get with Insights. Now, we also check for known vulnerabilities. We have compliance dashboards, policy, a whole bunch of automation so you can kick things out to Jira, et cetera. There's a lot here. I'm not going to show you everything that's in Insights. If you're looking to save money in your Kubernetes workloads, or you want to understand what it is that we're looking at, where I'm going to come back to that poll in just a second. We have a Kubernetes Rightsizing tool in Fairwinds Insights. There is a free tier. You can go sign up, kick the tires, learn. It takes just a few minutes to install the agent, get it working, and start getting reports. So at our free tier, you don't get all the clusters, you don't get all the access, but you can go see what kinds of things Fairwinds Insights could do for you. So go check that out. But before I come to this call to action, even though I just did the call to action, I'm going to back up a slide and we're going to do one more poll to wrap us up. What's the greatest opportunity to improve your Kubernetes environment? Is it A, get some more help with basics, B, a general best practice assessment, C, improve the security posture of your clusters, 4, saving money, and F, improving the reliability of apps running in Kubernetes. I just realized when I was on item 3 that there's no A, B, or C, so I decided to just play with it. Spend a second submitting that. We'll see those results as they roll in. Can this tool give recommendations like to use spot instances in AWS to save money rather than using on-demand nodes, Robert?
Yeah, I mean, that is definitely a good general recommendation. Spot instances, if you can handle the thrash that creates, where there are nodes kind of constantly, entering and disappearing from your cluster, if your apps, are properly architected and highly available, et cetera, Spot's a great way to save money. We do offer a lot of information about node usage, which can help you decide which node types to run. We don't provide node recommendations directly within the app, but we actually do have some services around that. So we can help your organization take a look at what's in your environment, what are your apps like, what are your reliability needs, et cetera, and help you figure out which types of nodes you should be looking at, whether that's Spot or on demand, whether that's memory optimized, CPU optimized, big nodes, small nodes, et cetera.
Great. And that came in as one more question. If anybody else has questions, feel free to throw those in the Q&A. But as we're looking at this, the greatest opportunity to improve your Kubernetes environment is leaning heavily on getting help with the basics, getting started, and improving the reliability of apps. Oh, with saving money being top. I'm a very colorblind person looking at a very color-oriented poll here and completely missed the orange line. Like actually didn't see it. But that's the biggest one because I guess that makes sense. We're in a cost management for Kubernetes webinar. Yeah, great. So now I'm going to flip back over to this call to action here. What were you going to say, Robert?
We did get one more question about the extent of the Insights agent in the cluster whenever you're ready.
I didn't see that one. No, go for it. What is the extent of the Insights agent footprint in the cluster? How big does the footprint get?
Yeah, so it's fairly small. The Insights agent mostly runs as a set of cron jobs, which will gather some information and send it back to the API roughly once per hour. There are a couple of tools that have a larger footprint, like Falco, for instance, is something we plug into. Falco runs as a daemon set, so you've got something running on every single one of your nodes that has a bigger footprint. But what's nice about the Insights agent is you can pick and choose which of the things you want. So running at a total minimum, you're basically using almost nothing because you've just got a tiny cron job running for a minute every hour. At its maximum, it can get fairly large if you want to enable the advanced tools like Falco. But for the most part, I would say, it's using a couple CPUs and a couple gigs of memory total. And it's usually using that only for minutes at a time rather than having a long-lived process. Hopefully that answers.
And it's intentionally built to be lightweight so that it doesn't cost you a fortune to run. It's supposed to help you. Well, it's supposed to help you save money. It's supposed to help you correctly set things up, okay? The entire product, Fairwinds Insights, is helping you approach the problem of how do I in Kubernetes. And from the cost side, we approach that not from we're going to save you all the money, although we often save people a lot of money because people tend to over-provision. That's the mistake most people make, so they tend to save money. But if you're the kind of organization that wildly under-provisions and your users are having a bad time, we're going to show you that as well. So.
Yeah.
Okay, and without further ado, without any more ados, with no more do's, I'm going to hand it back over to Cody to wrap us up. So thank you, everyone, for coming, and go sign up for Insights. We used to not have a free tier, so this is a big deal. You can just go sign up and kick the tires now, and you can play with it and save some money right now. It costs you nothing. And Cody, all yours.
Awesome. Kendall, Robert, thank you both so much for joining me today. It's always a pleasure getting to catch up with you in our pre-webinar meetup. So it's nice to see you guys again.
Likewise. Thank you, Cody.
I'd like to remind our audience that the session was recorded. So should you want to rewatch, you will be receiving an email with a link to access the recording on demand. Or, of course, you can find it living on the Container Journal website at containerjournal.com/webinars. The 4 winners of our $25 Amazon gift card drawing are Francisco M., Richard P., Helen K., and Raminder S. So to our 4 winners, congrats. Keep an eye on your inbox to claim that gift card. It should arrive in the next 48 hours or so. If you don't happen to see it, please do check your spam folder just in case it gets filtered out. I'd like to thank Fairwinds for sponsoring our program today, and to everyone who has been here for the last hour. Thank you so much for being here. We really appreciate and value your time, and we really value your feedback as well. As soon as we close out, there will be a survey that pops up. So let us know your thoughts about what you just sat through and what you just learned, or what you'd like to see maybe on an upcoming program. Either way, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day. And Kendall, Robert, again, thank you.